Hello, everybody. Good morning, good afternoon. Welcome to our about 1 hour session webinar on sensitive equipment decontamination with FastAct dry decontamination. I just turned on my camera for a second. My name is Dieter. I'm Austrian. I have been working as a CBRN consultant with Timlon now FastAct for a number of years. And I also run a lot of field trials and testings with the product. So what I'm going to do now is in the next about 45 minutes, roughly, I will introduce you, and apologies for those that have attended some of the previous webinars. It's a short revision on FastAct. What is FastAct? Then a few slides on sensitive equipment, current definitions, what is out there, decontamination of sensitive equipment in general, but very short. And then we move into the main topic of today's webinar, which is FastAct and sensitive equipment, and of course, the use of FastAct for the decontamination of sensitive equipment. And at the end, as Letitia mentioned before, we have the questions. So what is FastAct? And already here on the mid, you see here a bit covered by the glove, the finger. FastAct is a dry decontamination, but it's not only for surfaces, equipment, it's also for skin. And a bit on the history of FastAct. Initially developed a lot of R&D, research and development efforts, went into it at first for the destruction of the CW stockpiles in the US, and then later on, of course, also in the area of toxic industrial chemicals, the TICs. It's extremely important to understand that FastAct does not only work against chemical buffer agents, it also works against toxic industrial chemicals. It works against the unknown. That's where it's very easy to use, actually, and I will emphasize that a number of times. How FastAct works and safety, please feel free to reach out to us if any of you want some reports on the efficiency. So how does it actually work? We have tons of test reports, third-party testing, and also on safety. And you can imagine you need a lot of safety and efficiency reports, testings that you need to provide if you want to achieve CE certification, which we did in Europe with actually 2 products now, the mitts and the wipes. So feel free to reach out if you need additional information. As I said, a lot of testing has been done, not only with simulants, but with actual agents and also toxic industrial chemicals. So it has unique chemical reactivity characteristics. For those of you that have a chemical background, if you're really interested in the decomposition routes, reach out to us. It's not part of this webinar now. We can send you information on that. Or also go to the website. Under resources, you find a decontamination guide that outlines a few things on the reactions as well. Already, as you can see on this slide, FastAct comes in many ways and forms because it's a powder. So it's ready to use, very easy to use. You need very little training. You can literally not do too much wrong while using it. And it comes in different bags, sizes, and even in pressurized cylinders against vapors, and also for emergency decon of surfaces. Patents, I'm not going to read that out to you. You have it in front of you. There are a number of patents on this particular product. Those here are just some examples. It's not an exhaustive list, so there are lots of patents on FastAct as well. A lot of testing, as I mentioned before, that has been done. Not only testing, also field trials. Also, some of the testing was quite recent. For instance, DSO Singapore did quite some extensive testing on FastAct, also FastAct in pressurized cylinders. Interestingly enough, not its use against vapors, but its use on surfaces and on unprotected individuals. So this is a test report from 2023, and all the rest is throughout the last 15 to 20 years. Also, the OPCW has done some extensive testing on FASTAC. And OPCW, this Organization for the Prohibition of Chemical Weapons, also does have FASTAC in its team decontamination kit as well. One thing that FASTAC does, it does three things. So it decontaminates, contains, and neutralizes. So we call it the decontamination, containment, and neutralization. And here on the screen, you see a list, but of course not exhaustive, on the various forms or various chemicals against which FASTAC is working extremely well. And of course, also chemical warfare agents. So as I said, if you want to know more about it, go to the website, fastac.com. As I mentioned, it comes in all sorts of different delivery systems, but this is not part of this webinar. But I just wanted to throw it in, especially for those that have never been part of our series of webinars, that they have some sort of preliminary information before we enter into the details and jump into the decon of sensitive equipment. Some examples, who is actually using FASTAC for now. The list is getting longer and longer. Those are just some examples. And you see here, we have police units, we have fire units, military, special forces, we have the Navy. So there are all sorts of organizations like the OPCW that use it as well. I mentioned neutralization, which means destruction, certain ratios, certain timings. But of course, it always depends on the ratio liquid versus powder, and also the time, the contact time. Again, just some examples, but that you see that we do have all the test data when it comes to that kind of thing. Now, this is something that comes up a few times in the course of this webinar. Fast and forward decontamination. We all know that the time of decontamination is an extremely crucial factor for decontamination, and especially when we talk about sensitive equipment. Sensitive equipment, a lot of it is really our off-the-shelf, commercial off-the-shelf products. And when they get contaminated, the earlier you're able to decontaminate, the better it is. That means the more you can remove. There are very sophisticated solutions out there when it comes to the decontamination of sensitive equipment, specific chambers, large equipments, but they're not always available, and especially not always available right away. So that's why fast and forward, FASTAC is extremely important to understand that you can use this powder, and we will show you in a second how, also for the decontamination of sensitive equipment, and you can actually use it right away. You don't have to wait, and the faster you do it, the better it is. Those are just some examples of chemical warfare agents on different kind of surfaces, mustard on sand, shells on detection paper, just to give you some examples. Now, the question is, of course, what is sensitive equipment? And for this, we looked a bit at the definitions of sensitive equipment. There's not really one definition of it, but there is a sort of common understanding of what sensitive equipment actually is. This is a picture of the testing that we run, and I come back to that in a couple of minutes. So sensitive equipment now can be, as it says here on the screen, it can be part of personal equipment. Now, what does that mean? Personal equipment, usually every individual, whether it's a first responder, a soldier, they should have some kind of decontamination media on them that they could use for the immediate, as the military call it, decontamination. And FASTAC, as I said before, offers here, for instance, the mitts or the wipes that are also certified for skin. So sensitive equipment can be part of the personal equipment, or also material and any kind of equipment that is critical for an operational to perform a mission. Now, NATO lists the following main groups of sensitive equipment. Yeah. Flight critical components, computers and electronics. And why did I write that in caps and in bold? Because the tests that we have run, at least the first ones I'll show you, have been with electronics, computers, optical devices, or other components. Could even be, for instance, expensive robots. So there is a number of pieces that fall under this kind of list. And this is what NATO actually says, what is sensitive equipment. Now here, when you look at, it's just another thing, US Army, when you look at the JP311, the last version of it, they immediately link it to decontamination. And here they say it's certain types of equipment, avionics, again, same like NATO, electronics, environmental systems, aircraft, vehicle interiors, etc., etc. So, and even some weapon systems, yeah. So, and weapon systems can be small, they also can be large, and you don't want to lose too much time between, as I said before, the contamination and the decontamination. There is a bit of a movement now that has started when you look at the classical understanding of decontamination, those big, huge decontamination stations that are set up 20 to 50 kilometers behind, if we talk military terms, the front lines. This will for sure change also as the recent war and conflict, Ukraine and Russia, has shown us, because these decontamination stations would be prime targets. And also it takes a lot of time to reach them and perform decontamination. And that's why it's so important, especially when we talk sensitive equipment, that you start your decontamination process as soon as possible, preferably literally minutes after the equipment has been contaminated. And for this, you need something that is really ready for use. You don't want to start mixing stuff, and especially not using decontamination media that are also harmful to the sensitive equipment. Now, decontamination of sensitive equipment, when we look at some of these organizations, as I said, like NATO, for instance, they all say that those classical decontamination media, like wet systems, and some are quite corrosive. If you look at some of these decontamination liquids, they cannot really be used with sensitive equipment, especially when we talk electronics, when we talk optics, optical devices, or other things. You don't want to use anything that can harm the sensitive equipment. So you need to look for an alternative that you can use right away, fast and forward, and that doesn't really do any damage to the items or even lead to a degradation of their performance. So I'm not going to read that out to you. You have it on the screen in front of you. NATO, of course, says, well, the best would be that sensitive equipment, when it's designed, built, manufactured, that the manufacturer already takes into consideration that they should harden it against CBRN contamination. That's very difficult to do, as we all know, and most of the time it's literally impossible. Yeah. So the hardening, and also some tests that have been run in the past, you might get the surface clean one way or another. You might have damaged the equipment, but also, of course, what happens is the longer that you wait, the more of especially chemical warfare agents or chemicals might permeate into the material that needs to be decontaminated. And when we look at some of these materials like computers or other things, if you wait too long, then it will be very, very difficult to decontaminate them even down to a safe level. So NATO, and here we have, again, US Army, JP311. They specifically mention the corrosive properties of most decontamination solutions. So, and they say that sensitive equipment decontamination options are limited, and I agree, there are not really too many options out there that do not damage the equipment in any kind of form, and also that are ready to use and can be used right away. Now, the option here that is mentioned in JP311 is, of course, employing contamination avoidance measures. Great, of course. But if it gets contaminated, you need to take action. Yeah. And again, fast and forward. That means you need to have something that you can use right away. And as we have seen before, sensitive equipment also forms part of or is part of personal equipment. So that means the warfighter, the soldier, the responder, they should carry something on them that they can really perform decontamination, not only for themselves, but also on their sensitive equipment relatively right away, meaning it gets contaminated, you start the decontamination process. Now, FASTAC and sensitive equipment, before we move into the trials and some examples. FASTAC and sensitive equipment, that's actually quite easy because FASTAC is a powder and it does not degrade sensitive equipment. It's not corrosive, as an example. Yeah. And I just put on two different pictures here, which means it shows you skin. So you probably wonder, why is he putting in skin? Well, if FASTAC is safe to be used on skin, it's also safe to be used on sensitive equipment, and it's dry. Somebody might say, well, also water is safe to use on skin. Absolutely, I agree. But if you use water on sensitive equipment, we all know what's going to happen, especially when it's electronics. So FASTAC is not degrading sensitive equipment, and this was one of our main goals also with the trials that we have run to see what it really does to sensitive equipment. This I just threw in the MIT because the MIT will also come up again during the trials that we have run. The MIT and now also the wipes have a CE certification. That means they can be used on intact skin. And you can remove chemical warfare agents and toxic industrial chemicals from various surfaces. We have run tons of trials and tests on that, and also with removal rates, analytics afterwards, here detection paper. But we also have lots of analytical results as well. So this is basically just telling you that FASTAC is safe to be used on sensitive equipment. Of course, it's a powder. So some equipment might not like the powder component, but this has nothing to do with FASTAC and its properties, meaning the chemical properties. It has to do only with the fact that it's a powder. Now we move into the FASTAC and the decontamination of sensitive equipment. So when we designed the exercises, let me go back 1 second. When we designed the exercises here, and you will see them, and I have more pictures and short videos on that. We wanted to see at first is, of course, how much can we remove? That's one. And two, also, what does it do to the equipment? So we used functional computers, and we subjected them to 6 decontamination cycles. So various teams went through. We always recontaminated the computers, so 6 decontamination cycles, and I will show you in a second. And also we put a lot of FASTAC on it overnight, 20 hours, to see what would happen to the equipment, if anything would happen, and if the equipment is still functional afterwards. And this is what we're going to look at now in the next couple of minutes. So decontamination of sensitive equipment, and again, this is a statement from one of the NATO reports. We have more commercial off-the-shelf or military off-the-shelf equipment. And we have lots of computers. We all know that. So you need to have something that is extremely easy to use, that you could use right away on sensitive equipment without even thinking. And that's why we are convinced that FastTech definitely fills that gap. So live agent field trials. So as I mentioned before, I have been with Timilon now for a number of years. And every year, each and every time I get my hands on a live agent, which is a number of times per year, I always run field trials and various stations. And the good thing is here that the people that are using FastAct receive very little training on it, because the main focus here is not, when you look at some of these courses, is not really FastAct. So they receive very little training, which is something that we also claim, that the layman basically can use FastAct with little to no training, because you cannot do anything wrong per se. It's extremely easy to use. So here we used, for these trials, we have used powder in itself in those small bottles. Then we used the wipes, we used the mitts. So we used a combination of the three. And at some time, I even left it up to the operators. I know that a lot of decontamination testing is always done in a laboratory setting. In a laboratory setting, FastAct has performed extremely well. Tons of test reports show that. But the trick is always when you bring in the operators, and the operators are using basically the equipment in its different forms and functions, does it really work? Can the operators get it to work? And what are the results? And now, as I said, one of the main thing is establish and verify the functionality. So you see here the keyboard. Does it still work? Yeah. Then how much of the agent could we actually remove? And last, what I mentioned already, familiarize the guys that were using it with the procedures and the equipment that can be used for sensitive equipment. Yeah. So, and these trials have been run in Austria, where, as I said, we have access to chemical Wolfer reagent, and we use it for our trials next to also industrial chemicals. Now, the first thing is here, you can see, and I circled it red, is decontamination, contamination, and you see the, so to speak, contamination density. I know when you look at some of the recommendations from NATO, and you look at those battlefield concentrations that you normally find, the contamination density for sensitive equipment is much, much lower. Yeah. So, but in essence, when something happens, I think the contamination density might be as high as you have it in those battlefield concentrations. Yeah. And here later on, I give you the numbers and figures how much of this actually we used. So here you see the droplets, and you see here when the guy is using those buffer bottles. And as I said, these people had literally zero training on the equipment. And also I did that for a reason, so that to show that those FastAct items don't really require a lot of training. So here with the puffer bottle, of course, initially those guys were very cautious. They didn't want to put on too much of the powder onto the laptop. But I told them, and that's what my hand that always comes in, I said, come on, put it on there. Cover the spots that you have identified visually with FastAct powder. Yeah, and that's what they're doing. So they're putting FastAct powder on it, and you can see also in between the keyboard and everything else. Yeah, and this is an element of one decontamination cycle, and We did it 6 times with the same laptop. So recontaminated, decontaminated. So we did it a total of 6 times. Okay. So here now, next element, the wipes. So you can combine these wipes, and I come back to these wipes a bit later. You can combine them with the powder, whether you want to combine the wipes, the mitts, just use the powder itself as you wear gloves and apply it even then with your hands. Anything is possible. So there is no really a right or wrong in this. But here we let them use and even choose themselves, even at times the sequence or which type of equipment they want to use. Yeah. So here you see the guys are using the wipe that we also have. The wipe is a bit moist, but not to the extent that anything liquid comes out. The wipe is also certified for the use on skin. And the wipes is also certified for the removal of radioactive particles. So with the wipes, you can also remove radioactive particles. So again, here you see the result of one of these decon trials. And it must be clear to everybody, once you have a contaminated computer, if somebody says, well, we will get it 100% clean, this I want to see. Because even when you look at NATO accepts a certain residual contamination after immediate operational and thorough decontamination. Okay. And so there we have this 15 minutes touching, unprotected, without any health effects. But there's still some, not much, some of the agent can be left. Clearance is this 100%, which is extremely tricky, and there are lots of discussions. It's part of working groups. How do we even achieve that? And when you look at a keyboard here, and of course, when the keyboard gets contaminated, the liquid and whoever spilled ever something liquid on the laptop, people know that you want to really remove it as quickly as possible before it even goes inside the computer. And that's, again, this fast and forward. So if something gets onto your electronics and you have the decon media with you, which is powder that comes in forms that individuals can carry it, you can do it right away. If you wait, it's not only that the contaminant goes into the cracks that you see, but of course, here we're talking plastics, rubbers, polymers, whatever. And we have run tests in the past where, you might get the surface clean, but of course you still find some agent inside the material itself that has permeated inside over time. That's why it's so important. Decon as quickly as possible. So here now, as I mentioned before, we had the buffer bottle, the little bottles with 50 grams of FastTech powder. And now we have the mitt. So one guy also used the mitt. So first the powder and then the mitt. Yeah. When you use the mitt on skin, it's good that you pad. But when you use it, of course, on equipment, you can wipe as well. And what you see here is already the guy wipes over the keyboard. So there's a lot of powder in between and in all those kind of cracks and whatever. And we did this 6 times with a functional laptop. When you have electronics and they get contaminated, it's important that you be able to retrieve the data. Yeah. So because that's the most important thing, because I don't think that anybody is dreaming of having it 100% clean afterwards, clean to the extent that you can even bring it home. But with FastTech, you really have the possibility to remove extremely quickly and fast right away as much as you can. And initially, what we did here is we used detection paper. So US terminology M8. In Europe, we have, for instance, the Khalid detection paper, and we have 0.5 microliters limit of detection. I personally think it's even lower. Even with less, you see a discoloration. So that's what we used to basically confirm that nothing was left. And I will play with the numbers in a second as well. Yeah. We also had handheld devices, of course, like the LCD33. So now here you see functionality. So after the 6 decontamination cycles, the laptop still worked. And then what I did is, because I wanted to see what does the powder when I put it onto the laptop and I let it sit there. So after 6 decontamination cycles, I covered the laptop in FastAct powder, and you can see much more than the guys had used before. And I let it sit there for 20 hours, just like this. So the computer was sitting there for 20 hours. And after that, and I show you just a short video, it was working. Okay. Of course, now the question might be, what do I do with the powder? Well, of course, the powder, one way or another, you have to remove it. Yeah. There are specific, special, whatever you may call it, small vacuum cleaners with HEPA filters, as an example, that you could use to remove the powder. You shake it off into plastic bags. You brush it off into plastic bags. So there are a number of things that you can use. We used, for instance, pressured air. So we used a compressor to get it out and get it off. But after all of that, the computer was still fully functional. Yeah. So, and this is just a short video. You see here the mouse going on the computer, and it's all the thing was still working, so there were no issues. It started up, and you see here after the cleaning process, it's also relatively clean. So we removed the powder. As I told you, we used pressurized air, and we got all the powder off. So we really managed to get it clean. Residual contamination, I told you I play a bit with numbers. So we applied up to 260 milligrams of contaminant, and we could not find any kind of liquid contamination exceeding 650 micrograms. Yeah. So the detection limit is 0.5 microliters. So with the density, whatever this comes up. So this means at least on the surface, 99.75 of the liquid was removed, if you want to play with numbers. Of course, if you disassemble the laptop, you put it in ultrasonic bath and these kind of things, you might see how much of the agent actually would permeate into the material of the laptop. But as I said, it's extremely important that you perform your decontamination as quickly as possible. You might have very technical solutions at hand, but then before you can use those solutions, time elapses. And time means that the contamination actually gets worse and decontamination even harder. So we could not, as I said, after that, we could not manage to find anything with the Khalid paper. And also here, you just see the quick sampling process with the LCD. Also here, nothing really happened. So, but again, this is a very crude methodology to actually look into that, because the instrument needs, of course, a specific amount of vapor to even trigger. It's a point detector, not too much air gets sucked into the instrument. But those of you, and I know some units, they check the results of the success of decontamination with handheld devices. So just to show you, here we couldn't detect anything anymore. So this was an example on laptop electronics. And here I just want to show you a few slides, not on containment, but also other sensitive equipment where we ran some exercises with simulants. This we couldn't do really with agent. So you see here extremely high contamination density. We covered it with FastAct. And then you will see now we used sensitive equipment and we used a robot of an IED EUD unit. This was not a training tool. This was actually an operational robot. And the guys didn't have a problem to drive through FastAct because they have seen us working with FastAct for a while, so they didn't really have an issue driving through FastAct. Yeah, Simulant, of course, what we used was a specific chemical mixed with oil, and so here the robot drove through FastAct. Of course, we had the containment. We also verified the containment. So when you cover contamination on the ground with FastAct and then you drive through, you contaminate your equipment much, much less compared to you drive through actual neat agent. So also the spread of the contamination, these kind of things, this is just some side information here. But as I said, operational robot, and nobody would allow you to use, for instance, one of those corrosive decontamination liquids on an operational robot. Because we all know, and I'm not mentioning any of them, especially the new water-free chemicals, what they do to equipment. They're really corrosive, they're really bad, and nobody would allow you to use it on their operational equipment. I doubt it even on training equipment, because even after that, it's not functional anymore. So, and then we looked at the residues of FastAct on the robot and if we could get any kind of detection results. And then we compared it. We drove the robot through the contamination, yeah, without FastAct. And here you see you widely how much you actually spread the contamination, yeah. And for me, as I said, this piece of equipment is also sensitive equipment. It's very mission critical, especially for EUD, IED units. This is here, you just see the difference between the FastAct tracks and the tracks of actually the oily simulant liquid that really sets off detectors as well. So without FastAct here, it's just FastAct residues on it because we drove through FastAct first and then through the simulant. That was not covered. And again, there was lots of FastAct on the robot and without getting any kind of detection results here. But here, of course, we had sort of, so to speak, neat simulant on the robot. So you'll see it here. You see the detection of the simulant on the tires that drove through the agent right away. Yeah, and here you see it with FastAct. The result was a different one. Yeah. So here you see, and that's why I wanted to show you. We used FastAct on sensitive equipment. So we used FastAct and we used quite some FastAct on the robot here. This is a ½ kilo bottle that we used on the robot with the MIT. And again, you see, you can use these type of equipment like the MIT to help to apply FastAct on sensitive equipment. Sensitive equipment does not only have to be electronics. Unfortunately, we didn't have a helicopter or stuff like that, but we had a robot, so we used that one. And you see here how they actually apply it, and they were very happy for us to do that because they knew that FastAct would not harm the robot in any kind of way. Yeah. So you see here the powder, and if this is a corrosive liquid, they would not let us do that. Then, of course, they performed wet decontamination. But here again, when I asked them which kind of wet decontamination would you use on the robot, and that's what they used also for this. So for them, there would be no difference between training and operations. It's water and soap, like you use in the shower. And we all know that for very specific chemicals, like chemical warfare agents, most of them, water and soap is not really the ideal decon solution. So you see here, that's what they did. That's what they have. So they used water and soap. Again, look at this picture here, how much FastAct we applied on the sensitive equipment, which means on the robot, operational robot. So side effect, the rinse off of the wet decon. So the rinse off, of course, was still alarming. Yeah. Then next step is just some example here. I mentioned before we have the pressurized cylinders, and even vehicles and electronics, and sometimes electronics, optical devices, whatever, are outside, not inside. You can use even the pressurized cylinder and again the MIT to apply the powder onto the vehicle. This is some decon and some stuff that we did on a military vehicle, on a US military vehicle. And again, they were happy for us to do that. Why? Because they knew we wouldn't harm the equipment. So we applied FastAct powder onto the vehicles. And as I said, sometimes the vehicles, not only inside, but also mainly outside, that's where they get contaminated, carry electronics and devices like even optical devices. Last thing that I have here is I mentioned before the all hazard wipes, and you have seen we use them. Yeah, we use them on the electronics on the laptop, and there was extensive testing was done with those all hazard wipes, or the decontamination wipes as they're called, and for the removal of radioactive particles, stainless steel, and also from pigskin. Now, those of you that are familiar with removal of radioactive particles from skin, they would appreciate that the average range of the average percentage of 38% is actually very good. Yeah. So it's very, very difficult to remove radioactive particles from skin. So with the wipes, we managed to do that. And that's why the wipes have also CE clearance for the removal of radioactive particles on skin. This is just a little sidestep, but it's the same wipes. So you see that when the warfighter, the responder, when they carry some of these FastAct items on them, they can use them on themselves, skin, equipment, guns, but also sensitive equipment like we have shown now with the computer, the robot, whatever. And very little training. So all the guys that you have seen in those videos, they had very, very little training. Sometimes they just had a quick run through. You show it to them, 30 seconds, 60 seconds, 1 minute, and then they used it. So very, very easy to use. Again, as I mentioned before, fast and forward decontamination. It's extremely important that you have something on you that you can start your decontamination process as quickly as possible. And this is also important for sensitive equipment. Now, this is the part where we move into the questions. I thank you for the time that you stayed with us now. And of course, I cannot stop without bringing this up. So should you have any further requests, here are the info. Here's the info on the sales guys, if you need them for any further information, if you have some requests. Also, Letitia, you can reach out to her, or you can also reach out to me. So thank you very much.